Now, with that, I need to look at our cell potential equations. How to balance a chemical equation, acid, base, what have you. You can go through it systematically in a few short steps. If I say Fe2 plus goes to Fe2O3, well, actually, we'll say Fe dihydroxide goes to Fe2O3. We'll just say, okay, there's that reaction. And there's another half reaction that goes copper to oxide goes to copper solid. And we'll do this in base. All these are solids. So to balance this chemical equation, there's some steps you need to take. First, you split into half reactions. We have our iron hydroxide and our copper oxide. That's copper 1. That's iron 2. There's going to be iron 3 and copper neutral. Do you have to know that? No. The beauty of this. So step 1, we split it up. We split it up into our two half reactions. Step 2, we balance our non-oxygen, non-hydrogen elements. So for us, that means doubling the iron on the left. For this guy, it means doubling the copper on the right. Step 3, we add waters to balance out the oxygens. We add waters to balance out the oxygen. So there's 3 oxygens here. There's 2 times 2, 4 oxygens there. So to balance this guy, I'm going to add a water to the right side of the equation so that there is 4 oxygen. There's 4 oxygens on both sides. For the copper situation, I have to just simply add a water on the right side. Now, with this in mind, step 4, even if it's in basic situation, even if it's in base, we need to add hydrogen. It's going to make this so much easier if you just add protons here to balance these guys out. To balance these guys out, there is 2 hydrogens on the right. There is 2 times 2, 4 hydrogens on the left. So I am going to add 2 hydrogens to the right. H2O plus 2 protons. This guy, there's 2 hydrogens on the right. There's 0 hydrogens on the left. So I'm going to add 2 protons to the left, sorry. 2 Cu and water. Now, the step 5, we're going to add electrons to make both sides the same charge. We can only add negative, so you have to bring the positive side down to the lower charge. The charge on this side is 0. The charge on this side is 2 plus. So what do we got to do? We have to add 2 electrons. Now, this is where I differ from the book. The book would suggest that you should find your charges, find the charge of your metal, and then figure out how many electrons are lost. by figuring out how the oxidation state changes. This goes from 2 to 3. It does it 2 times, so 2 electrons are transferred. However, this is much easier, especially when you have complicated reactions. Mine is much easier. However, sometimes you actually need to know the charge of your metal. Now, on this one, there is 2 plus on the left and 1 plus and 0 on the right. So I have to add 2 electrons to the left. Now, the last step, or second to last step, is you find the greatest common factor and multiply both equations by the greatest common factor so that the number of electrons lost equal the number of electrons gained. And then you add the equations together. So 2 and 2, the greatest common factor would be 2, so I'm multiply both sides by 1. So when I add these guys together, I don't have to really do anything. I'm going to put the whole equation as written, and we'll cancel out from there. 2 electrons and 2 protons, and copper 2 oxide goes to Fe2O3 and 2 protons and 2 electrons and 2 coppers and water. Okay, everything that appears on the left and right side gets canceled. So 2 electrons, 2 protons, 2 protons, they get canceled. Oh, I left out a water. So now these 2 waters can add up. So our 2 iron hydroxides and Cu2O goes to Fe2O3, 2 coppers, and 2 waters. At this point, if this is in base, you would have to swap the protons to the other side, and if this was in base, you would have to acid. For example, if there's a proton over here and a water over here, they swap places, and H plus becomes OH minus. But it turns out this one doesn't matter whether it's an acid or base. You have the same generalized reaction. The same generalized reaction, that there's water on this side, there's no acid. So all the acid got canceled out. So acid or base gives you the same value. But that is how we balance the equation. If you follow those 7 or so steps, you should be able to balance just about anything. Some of them don't need to be done. Some of them, like if there's no oxygens, you don't have to balance the oxygens. If there's no hydrogens, you don't have to balance the hydrogens. But sometimes you have to do all the steps.